Okay, so hi, we're the Paramount team, and we built an AI that can detect negativity in text using sentiment analysis. So this is our team. I'm Sama, along with Lincoln, Jeremiah, William, Brooks, and Ryan was our TA. So our motivation for this product was that, especially as the world is embracing technology as our main mode of communication, we've noticed that negativity is easily spread on like social media, and so we wanted to take the opportunity to use AI as a tool to stop the spread of negativity.
And here's our website where the user will find the interface for entering text where they will receive a message saying if it is negative or not. And now we'll play a short demo showing the product. So as I mentioned earlier, the user is going to input some text. And as you can see, it's above 50%, indicating that it is negative. And in this case, it's below 50%, so it's non-negative. And here's some other applications on social media platforms like Twitter, Instagram.
Brooks,
Yeah,
can
sure.
we try a live demo?
Yeah.
Yeah, let me reshare my screen.
Let's try a live one. And also like, we should have other folks writing down whatever they want to write, and then we can try that. Right?
Okay, does someone have the website
I
link?
mean, I don't want to see a recorded session,
Yeah, it's in the Discord.
Okay. Here's the website that you can try it out. Oh yeah, there.
Someone, can you actually just screen share? You go there.
Yeah.
And then, we should, we should put in some text and see what the, what this AI is going to say, right?
Okay, so what should we type?
Today is a raining day and I cannot go out to play basketball.
It detects a negative sentiment.
That's pretty good.
Should we try something positive?
Yeah.
Maybe I can.
Viver actually say something like, what an amazing product. Viver said like in the chat.
Oh, what an amazing product. Okay.
Oh no.
Well,
So this is wrong.
it's not perfect, but yeah, it does work most of the time. But yeah, so it detects the sentiment, and that's what works on the live website. Okay, let me reshare the presentation. Okay. So yeah, I think Brooks was talking.
Yeah, so these are just some other examples like social media platforms on Twitter and Instagram, and then maybe for messaging apps as well.
So we needed to find a data set that could represent a wide range of tweets. We found a data set using Kaggle, and the data set had around 30,000 tweets. Each tweet had been assigned a value, either 0 or 1, where 1 would represent a negative, sad, or mad sentiment, and 0 would indicate a positive, happy, or neutral sentiment. After separating the tweets into positive and negative sentiments, we split both categories apart and randomly shuffled them. We then began tokenizing the text while getting rid of punctuation, stop words. We lowercase the text. We got rid of links and as well as Twitter handles that start with that symbol. Then we stemmed every word. Could you go to the next slide? Yeah, and so we split that data into training set with 25% being the testing set and 75% being the training set.
So in developing our model, Ryan, our TA, actually recommended that we built our model on the CARES API. It is a deep learning API that makes it very easy and seamless to set up a model. So for our model, we at first had 5 layers in it, but we found after some further testing that 3 was just fine for what we were doing. So we had first layer being an embedding layer, and then second one being a LSTM. That's the RNN that we decided to use with 2 hidden nodes, and then our last layer being a dense layer. So we trained our model for 5 epochs. We were able to create a confusion matrix for both the training run and the testing run for our model to visualize the data.
So in testing model, we grabbed our testing data set that we ourselves made, and we passed it through the model. We ended up getting a 0.79 F1 score for this test run, which is not too bad for our model. So F1 score is a weighted average of precision and recall. It's a bit harder to understand, but it provides better metrics to better the model. So here's the heat map of our test, where our actual sentiment and our predicted sentiment. So in the bottom left corner, we have non-negative sentiment is predicted, but the actual sentiment was negative. And in the predicted sentiment in the bottom right corner, you have negative predicted sentiment, but where you got where guess that it was negative. And then in the top right, you have predicted it was negative, but in actuality it was non-negative.
Can we actually slow down a little bit? Can we go back there? Because I don't think most people heard what you're saying. Like, because I think there's some connectivity issues. Is there a way that like some of other team member can help here? Like,
Right. So what he was saying is that in the bottom left corner, we've had 2 cases where a negative tweet was identified as non-negative, and in the bottom right, we had 23 correct tweets that were identified as negative. The top right, we had 10 non-negative tweets that were identified as negative.
So did we see that in the actual demo?
No, this is part of our first testing run with using 50 tweets.
No, but I was just saying, like, for example, like when Weaver said, like, we want to input that, what an amazing product, right? That's a positive thing, right? But you can see here, like 40% of chance, right? 40% chance that's going to classify as negative though. Do you guys see that? Because it's basically 10 out of 25, right? So it's 2 out of 5, this is 40%. So another 60%. So 60% of the case for the positive one is going to classify correctly, and 40% of the times is not going to classify correctly. So what can we do to improve this performance?
So with our data initially, from the get-go, our data set had like lots of examples of like non-negative sentiment. So it didn't really train, I guess, the negative sentiment part of the model good. Actually, our model, it focuses a lot on the negative cases. So I think that's one of the reasons why it kind of detects negative when it's supposed to be non-negative.
How many you had for the non-negative and how many you had for the negative in the ground truth?
So we had 20. So for our testing data, we had 25.
No, training.
Oh, training. Not really too sure. We also, that was one of the things we had to bring up too. One of the difficulties, we had to resample it. So I'm not really sure how much of each we had.
Who trained?
Actually, so we had around 2,000 of non-negative statements, and we had around like 650-ish negative statements. We basically heavily imbalanced the training data, because when we had an equal amounts of both, it got really good at detecting negative statements, because there were a lot of like key words such as like depression or like sadness they could pick up on. So in order to like basically like train it to get good at identifying it if it didn't have those keywords, we added in like a bunch of non-negative statements compared to
Got
a
it.
negative statement. Yeah.
Got it. Sounds like if you have more data, then you could have trained better.
We originally had like a lot more data, but then the training GPU, like it took too long to run, so we had to like cut down on it.
Got it. Okay, cool. Giving me enough time probably can improve this model.
Yeah, definitely.
Yeah. Okay, cool.
So we also wrote the code to load the model into the website, and then we built the design and the layout of the website. We practiced our presentations beforehand, and so now we refer to our model on the website, and anyone can try it out.
So yeah, there are lots of positive applications of our product. The basic obvious one is understanding text and its emotion, maybe if emotion was mistranslated or misunderstood. It can also help gauge for a potential mental health issue and then help improve it. And then it could also help with company assistance, like understanding a company's users and employees to create a better experience.
So yeah, some of the difficulties that we encountered, I said it before, but we actually didn't say it before. Initially, like I mean, yeah, we had 5 layers in our model. Obviously, with testing, it had a high test percentage or training test percentage, but then when we ran our testing data, it had a really low accuracy. That's the metric we went off of. So we saw it as overfitting. So we tackled the data set with like the resampling technique and all of that. And so like Michael recommended, in order to improve this model, can gather more data. Along with that, we could probably have more time to improve upon this model as well.
And yeah, so that's our product and this is our team. We had so much fun working on this project together. So yeah, thanks for listening.
Great. Can we give this team a round of applause? Great work. Definitely, fought through a lot of hurdles.
Say that you guys are great, that Michael threw a lot of things like, oh no, don't do this, do that, let's try something else, and then you guys like, oh, answer all the questions, and then TA just like, well, TA help, well, not really, but all the answers from you guys, and I think it's very, it's great. Because when we practice, we didn't expect that. We think like 5 minutes. So we just like, oh, present this, going through this, smoothly. We expect to be 5 minutes. And he was like, no, don't do this. Let's do something else. Try this sentence. So didn't expect that, I guess. So that, kind of, I was worried that, they would be nervous. They don't know how to answer your questions and everything. But I think you guys did great.
Yeah, he kept us on our toes for sure.
Well, yeah. To be honest, I'm just your biggest fan. And when I see, for example, this model can be improved, I can't help but just tell you, hey, like we can improve this way and that way. And, frankly, it's like, I think you guys did great, in terms of like, how, like you guys, how you handled like my questions and all that. And I really want to encourage like our parents, who are actually hiding here, right? We have 40 parents here and other students and TAs. When people are presenting, asking questions, right? Because, we care about, how you made this, how we can, do this better. Just imagine instead of you sitting here, listen to everyone talk, but you basically like can understand, everyone's model, how they would work. Don't you think that, you will learn so much during this short period of time? Right. So, definitely be more curious about it, Yeah.